How's it going? It's kind of like Monday morning for you guys. It's Thursday afternoon for me right now, but Monday morning, and so I'm going to wear my Virginia Tech hat backwards because I'm cool. And I'm going to talk about properties of exponents. And hopefully you're going to be watching this video after you've watched that guy, the funny guy, on those videos I sent out to you, talking about lesson 4 from our book. And if you look at the top of page 29, you have all those properties there that we're going to kind of, every single one of those properties we have to use throughout this chapter or this section. So what I'm going to do today is I'm going to explain these properties for a minute. Then I'm going to do about 7 examples, and this time I'm picking the hard examples to do, where I'm assigning you guys the kind of the easier ones. So on page 29, I'm going to do all the ones on the right-hand side, and you guys are going to do all the ones on the left-hand side for your part of your assignment. So now the properties. All these properties kind of harken back to properties we've already learned, but now we're mixing in the rational exponents, the exponents that are fractions. So for instance, break this first one. We got the same base. B is the base. So b to the m over n times b to the p over q. Well, that's b to a power times b to another power. So we add the exponents. Sometimes adding exponents is really easy, like if it was b squared times b to the third. That's just b to the fifth. That's easy. But this one's harder because we got these fractions we have to add. So we'd have to actually add the fractions, get the common denominator and add them. Okay. The second one, that's b to the m over n. And we had problems like this on our last assignment. And some of us did them okay, some of us didn't. B to the m over n, that n, the little n right there, becomes the index inside the radical. And the m on top stays as the exponent. So the b to the mn is the nth root of b to the m. Okay, these next two go hand in hand. This first one, b to the 1 over n raised to the n. Remember, power of a power, we multiply the exponents. So b to the 1 over n to the n is b to the n over n. You just multiply these together and they get 1, so it's just b. Same idea for number 4. This time it's the b to the n to the 1 over n. So it's basically the nth root of b to the n. That 1 over n and that n, they undo each other, so it's just b to the first. Number 5, we have the power of a product. So in the old days, if you had like ab to the third, that was a to the third times b to the third. Easy. Well, now it's a little different. Same idea, a little different application. It's ab to the m over n. That's going to be a to the m over n times b to the m over n. Same idea, little different application though. Okay. Very similar idea right here as what we were doing like here and here. We're going to multiply. So it's power of a power I should say. So we're going to multiply m over n times p over q. So we get b to the mp over nq. Whew. Got to multiply those out. And the last one, number 7, b to the negative m over n. Remember, negative exponents, take the base and make it a fraction. So b to the m over n is 1 over b. Now the negative is gone to the m over n. Okay, so these are the rules. We're going to have to know these. We're going to have to be able to use them. Now we're going to do a handful of examples. We're going to start with... I got the wrong one up there. No, I don't. 1D. 1D is right. That's the first one we're going to do. It's the first one on the right-hand side, right-hand column there. And what these directions say, and you know what? That's something I want to reiterate. Make sure you read the directions to the problem before you do it. So many people are turning in work from this most recent time, and they're not reading the directions. They're giving me answers, but they're not the same as what the question's asking, which makes me think maybe you're taking a picture of the problem and going on the internet and seeing if somebody will do it for you. I don't know. But you got to follow the directions. So the directions for this one say we're going to evaluate each expression for a is 27 and B is 64. So I wrote those up there, so they're going to stay there for these three problems. So A is 27 and B is 64. So we're going to plug and chug. We're going to put in 27 for A. We got 27 to the negative 2/3 plus 64 to the 3/2. Okay. 27 to the negative 2/3. Well, the negative means to make it 1 over 27 and keep it as 2/3. So we're going to have 1 over 27 to the 2/3. Then we have 64 to the 3/2. What that means, that's the square root of 64 cubed. That's the square root of 64 cubed. Okay? So now we're going to do 1 over 27 to the 2/3. Well, that's going to be 1 over the cubed root of 27 squared. And then we can do this one. What's the square root of 64? Anyone? Anyone? Yeah, what's the square root of 64?
8.
8 is correct to the young man in the back row. So that's going to be 8 cubed. So I have 1 over the cubed root of 27 squared. So the cubed root of 27, that's going to be 3. Right. So this is 1 over 3 squared plus 8 to the 3rd power. 8 to the 3rd power. That's 8 times 8 times 8. And I think that's going to be, yes, that is 512. And now we got 1 over 3 squared, that's 1/9, plus 512, that's 512 and 1/9. And that is a good answer for this problem. 512 and 1/9. There it is, yeah, good. Got that one right. That was a hard one. Let's move on now to letter 1E, the next one on the page. Okay, so we got a multiplication going on in here. We got different bases from each other. We got a negative exponent. We got a positive exponent. We got a quantity to the negative 1. Well, that's multiplication right there. That's multiplication. So what we can do power of a product. That's multiplication. Now, if that was addition, we couldn't do what we're about to do. But it's multiplication. So what I can do is take negative 2/3 times negative 1, and that's just 2/3. So that's going to be A to the 2/3 times, now I'm going to do B to the 3/2 to the negative 1. That's going to be B to the negative 3/2. Now I'll put my numbers in. I'm going to put 27 in for A. We got 27 to the 2/3 times, and we got 64 to the negative 3/2. Okay, now the problem looks kind of like the one we just did. We have 27 to the 2/3, and that's going to be the cubed root of 27 squared times, and that's going to be the negative exponent makes it a fraction, so 1 over 64 to the 3/2. Man, this looks so familiar. I can't believe how familiar this looks. So this one here is going to be the cubed root of 27 is 3, squared is 9. This time, I know I did 64 to the 3/2. I think we just did that a minute ago, and we got 512. So this time, whoops, that's a times. That's times. Times 1 over 512. And 9 times 1 over 512, that's equal to 9 over 512. And that is a great answer for the second one, for letter E. So again, what we did is to just recap. That's multiplication, so I'm allowed to do that exponent times that exponent, and that exponent times that exponent. That's okay, I can do that. Do that, and then I put my values in, and I worked it out. All right, letter F. Now this one is fundamentally different from the previous one. Fundamentally different in that that's a subtraction symbol, not a multiplication symbol. So I'm not allowed to do that exponent times that exponent and that exponent times that. Can't do that. Nope, I got to work this out, get an answer, then flip it. If I did this exponent times these, that'd be like a ceiling tile mistake. Just like a ceiling tile mistake, because that'd be like squaring a binomial, only instead of squaring, we take it to the negative first. Let me change up and go red here. So we're going to go a to the negative 2/3. I'm going to do two things at once to save room on this sheet. I think I'm going to run out of room. I'm going to put the 27 in, and I'm going to do the negative power. So I'm going to have 1 over 27 to the 2/3 minus 1/8 times 64 to the 3/2. All of this raised to the negative 1. So let's figure out this 1 over 27 to the 2/3. Well, we got to do the cubed root of 27 again. That's still 3. And we got to square that 3. That's 9. So this becomes 1/9. Minus. Now, you might be tempted to go like 8 goes into 64. Okay, you might divide that out. But you can't, because you got to do this exponent right here before you do this multiplication. So this stays 1/8 times. All right, now let's figure out the 64 to the 3/2. 64 to the 3/2. We've done that one a number of times in the last couple minutes. Square root of 64 is 8. And 8 to the 3rd power is 8 times 8 times 8. And that is 512. Again, the kid in the back of the room seems to be right on the ball. All right. So we have 512. So 1/8 of 512. And we're going to do that, and we're going to raise it to the negative first. So now we got to do 1/9 minus, 1/8 of 512. Well, that's really a hard math problem, except in order to get 512 a minute ago, we did 8 times 8 times 8. So we did 64 times 8 to get 512, and now we're trying to do 1/8 of 512. Well, it's got to be 64. So we're going to say 1/9 minus 64 raised to the negative first power. All right. I got to do 1/9 minus 6. I keep dropping my pen. I got to do 1/9 minus 64. All right. I need scratch paper. Luckily, I have a way to get scratch paper. Well, I'm trying to figure out 1/9 minus 64. 1/9 minus 64. I'm trying to figure out 1/9 minus 64. All right, well, that should be equal to 1/9 minus some number of ninths. And to get that number of ninths, I got to do 9 times 64. 9 times 64. Oh my. 9 times 64. I got to figure that out. 60. That's 640 minus 64. That's 6. That's 13 minus, that's 5. 576. So 1/9 minus 576 ninths is going to be negative 575 ninths. Okay. So that was 1/9 minus 64, negative 575 ninths. Let's take this down. Negative 575 ninths. Negative 575 ninths raised to the negative first power. Raising something to the negative first power means to take the reciprocal of it. Take it the reciprocal, flip it. So now the final answer for this one is going to be the reciprocal of negative 575 ninths. In other words, that's going to be negative 9 over 575. And that, my friends, is the answer to letter F. Okay. Now, moving right along. We're going to jump down and do some examples from number 2, unless you have any questions. You have any questions? Okay, no questions. Good. We're going to jump down and do the examples from number 2. And in order to do that, I'm going to have to reload my little chalkboard here. Reload my little smartboard, I should say. And I got some problems to do here. Let's make sure I got them in the right order. Yes, I do. All right. We're going to put these guys up here. And make sure we read the directions as we go here. All right, the first question, looking at the directions here for number 2. The first question, or the directions say to, I need my glasses because the font is so daggone small. I hope nothing happened behind me. Oh dear. Anyway, the directions say rewrite each expression so that each term is in the form k x to the n, where k is a real number, x is a positive real number, and n is rational. Holy smoke. All right, well, let's see if we can figure out what that means, what we're supposed to do. After I get this thing reset. No worries. I'll just get some tape going up here. And we should be really flying. Good to go. Uh-oh, it's trying to jump down again. All right, we're going to just take that guy right there. Hopefully that'll be good enough to keep that up there long enough for me to do these problems. All right. So it says every answer is supposed to look like this. Have these terms, k, x to the n. So if we have more than one term, we're going to have more than one thing looking like kx to the n. So I got to do the cubed root of 27 and the cubed root of x to the 6th. This equals the cubed root of 27 divided by the cubed root of x to the 6th. All right? So the cubed root of 27, that's 3. And the cubed root of x to the 6th, that's x squared. Well, it's not quite right yet. Not quite in this format. So I got to rewrite it as this. 3x to the negative 2. Let's see if you can see where that negative 2 came from. Where is that exponent now? It's in the denominator. And so if I want to have it in this format, it's got to be put up here in the numerator. If I take this and put it in the numerator, that makes the exponent negative. All right, so now the second one, number 2, or letter 2G, I should say, it's 3 problems, and we got multiplication going on between them all. Make sure I copied that right. I did. Okay, so we're going to do the cubed root of the cube times the cubed root times the cubed root. So we can kind of figure all this stuff out. Let's see that we're going to do. This is x to the 1/3 here times, okay, the cubed root of negative 8. The cubed root of negative 8 is negative 2. So that's going to be negative 2 times x to the, all right, this is the cubed root of x squared is x to the 2/3 times, and now we got the cubed root of 27 is 3, and then the cubed root of x to the 4th is x to the 4/3. Now, almost done. We got to multiply these together, because this is multiplication times and times. And we got one negative and all the rest positive. So we're going to have a negative answer. We got a 2 times a 3, that's a 6. And now 6, or 1/3, pardon me, x to the 1/3 times x to the 2/3 times x to the 4/3. We actually, believe it or not, we have to add that exponent plus that exponent plus that exponent. And if we add those exponents, 1/3 plus 2/3 is 1. And then 1 plus 4/3. So I got to add 1 plus 4/3. So I'm going to add 3/3 plus 4/3 and get 7/3. So negative 6x to the 7/3. Shouldn't switch colors like that. But negative 6x to the 7/3, that's actually the answer to that problem. Pretty cool, huh? Pretty cool. Okay. Now, let's move on to the next one. Now, the next one is a little bit trickier. Next one's a little bit trickier. Okay, because this is like unlike anything I think we've seen before in our, as a group, as in Mr. Wilding's Honors Algebra 2 classes. I don't think we've done one like this in any context. So it's need a little bit of explanation, I think, in order for us to understand what's going on here. All right. I want to actually split this thing into 3 fractions. Watch this. I know usually like all your life, it's find the common denominator, add the numerators, whatever. Now, what we're trying to do is split this thing up so we can divide that square root of x into each of our individual numerators. But we're also in the same fell swoop, I'm going to change that x, the square root of x, to x to the 1/2. So we're going to have 2x to the 4th over x to the 1/2 minus x squared over x to the 1/2 minus 3x over x to the 1/2. Okay. All right, now I'm going to write the answer, basically. My answer is going to be 2x to the, now I got to do 4 minus 1/2. 4 minus 1/2, I know it in my head. 4 minus 1/2, that's 4 is 8 halves. 8 halves minus 1/2, 7 halves. That's 2x to the 7 halves minus, I'm going to have x to the 2 minus 1/2. That's 3 halves. X to the 3 halves minus 3x. Now I got to do x minus 1/2. That's 1. I'm sorry, I apologize. I got to do 1 minus 1/2. And that's 1/2. So this is the answer. That's the answer. The directions, remember, were to write each expression with terms that are k, x to the n. K for constant, and then x, the variable, and then to the nth power, and n was going to be a real number. A rational number. And these are all rational numbers. Rational numbers are like numbers that are fractions or whole numbers. Those are rational numbers. All right. Let's keep going. Last 2. I had 2 more. I got I and F left to do here. Let me put some tape on this guy before. I'm going to put some tape on this before it falls down. I think I got 1 more, just I. Sorry, I said I had 2 more. I just got 1 more. I just got I here left to do. All right, this guy looks kind of like the last one. Looks kind of like the last one. All right. So who thinks they know what we should do with this one? It's kind of like the last one. Right, we should split this thing up. So I'm going to have x to the 1/2 divided by 4x squared minus 2x to the negative 3 over 4x squared. And this is going to be 1/4. So 1/2. Now I got to do 1/2 minus 2. 1/2 minus 2 is 1/2 minus 4 halves. 1/2 minus 4 halves is negative 3 halves. So this is going to be 1/4 x to the negative 3 halves minus, okay, this 2/4, that reduces to 1/2. X to the negative 3 minus 2. Negative 3 minus 2, that's negative 5. And that, my friends, is the answer right there. That guy. 1/4 x to the negative 3 halves minus 1/2 x to the negative 5th. That's it. And remember, they wanted us to put the answer as k x to the n, in terms of k x to the n. All right, so the last thing before I say goodbye to you is a couple reminders that I just want to reiterate that I noticed as I was looking at your assignment recently. Some people, for some reason, they think when the book says this, they think that's 5 1/2. And they tell me that's equal to 11 halves. Okay, that's all well and good, but we're not like in 3rd grade. You're not going to have a math problem that says convert 5 1/2 to an improper fraction. I mean, come on. We're big boys and girls. That is 5 to the 1/2 power. 5 to the 1/2 power. 5 to the 1/2. Not 5 1/2. That was bad that you guys are reading that like that. In any case, the problem that we had on this, they wanted us to convert that to the square root of 5. That's what 5 to the 1/2 power is. In a similar vein, 81 to the 3/4 power, that's the 4th root, and that's 81 cubed. 81, you can either do like this or outside. That's easier to do it like this, because the 4th root of 81, that's what number to the 4th power gives me 81. And I don't know if that kid in the back knows that. Doesn't look like he does. What number to the 4th power gives me 81? Okay, let's try again. What's the square root of 81?
9.
What's the square root of that?
3.
Okay, what to the 4th power gives me 81?
3.
That kid is really smart. So that's 3 to the 3rd, and that's going to be 27. That's how you do that one. Okay, I hope this lesson or this video was somewhat helpful. And I'm going to say goodbye to you, and I'll see you next time here in my basement.